Welcome to my demonstration of our project. We're a team of Andrew Logan, Mike Bolin, and me, Devon Weaver, designing and building this project. I'm doing the video. That's my task today. We have it hooked up to that array over there. It's a 10-watt array, which is hooked into this barrel connector into our circuit project. This is the storage slash charger unit. It's controlled by a PIC 16877, old but useful PIC. It is showing green that there's enough solar power coming in at this time to charge this battery, which is a 1,000 milliamp hour battery. It's a LiPo battery, so it needs to be charged and protected specifically for that. So I have a Max 1555 chip, which is on board, the SparkFun koala board that I got for prototyping, and just makes it easier and quicker to use. The PIC controls either the solar or USB power. If it's on solar, it's green, and there's enough power at solar, it says yes. It's going through pin AN1 and 0 right here. That's an analog to digital converter. It's being used there, and I configured another one for the battery voltage. And the primary is USB, so if I plug in this USB, it should go red if there's enough voltage going in at the time. And I'll make sure I have it plugged in, which I think my battery needs to be charged more, so it's using the solar cell specifically at this point in time. Now if it goes bad solar, it will go yellow, not enough solar power, so the USB will kick in here hopefully after a few minutes. If not, then there you go. Now it's on USB power because the solar cell was connected and had enough power, so it wouldn't switch. Now it switches to USB, and that's the primary power. And since it is the primary power and more reliable than solar, it will stay on the USB power until it's connected. Once the solar power, the USB is connected, now it will, after 5 seconds, know hopefully to switch back to the solar power. Unless the battery power voltage is over a certain point, then it will stay red, saying that the battery's charged and it's good to go. So when it does get yellow, that means the battery is getting low, or the solar power, if it's connected, is in a bad situation. Now it's on solar, as you see. The PIC switched over to solar, and I have good solar power. Now I don't have good solar power, so I disconnected. So that's simulating that there is no solar power. So it switches over back to, right now it's in that point where the battery and the solar power are pretty good voltage levels, 3.7, 3.8, so it'll switch back and forth between yellow and red depending on what it's reading. Hence the values of the voltage through the analog digital converters. So the battery is charged good, so it can charge a USB device right now by itself, which I have my phone, which is right here. It's a pretty hefty phone, so I will connect it. I have my tripod here. So it's on battery power. I have to figure out which side is which. Should have it backwards. I always do that. Now, as you see, my device is charging. It has the charging symbol and is on the battery power right now. Now when it gets to yellow status, meaning the voltage is low constantly, the device will die eventually and drain the battery, but you can just plug it in the solar and it will recharge the battery and or the USB. More advantageous, you should plug it into the solar all the time to make sure you always have good power. When you have it available, might as well use it, and not use your storage battery for the emergency situations. So now it's going to stay red. Since the battery's good, it's charging. So eventually it'll go yellow and go back to solar power when it needs it. And it's all done logically through the PIC chip. And that's pretty much my demonstration. I did explode it. It would not look like this. It would look like this in this. And it would plug in to the back of the solar array or whatever array. So you don't have to carry that big thing around. If you want, you can plug any solar array you wish with enough power into it, and it will work. And that's it. That's our demonstration. Kind of a simple video for our product or design product. Hopefully it was good enough, and if there's any questions, you can email me at devon.weaver@gmail.com or djw82@zips.uakron.edu. And I hope you have a great day. Thank you. Bye.